Hi, you're watching DNA Today, a multi-award-winning genetics podcast where we explore everything to do with genetics, from CRISPR to rare diseases to new research. We have won the Science and Medicine Podcast Award for many years now. We have hundreds of episodes, and we really hope you enjoy these conversations where we dive into so many genetic concepts. I'm Dineen, a certified genetic counselor and your host. To celebrate the year coming to an end, we are reflecting back on the year in genetics and genomics and talking about the top news stories and big publications that have come out. And I can't think of two better people to join me for this conversation. This is a series we've actually been doing for a couple years now. And we just got back from the American Society of Human Genetics conference in Denver in early November. So it's perfect to have the outgoing president of ASHG and also the director of the NHGRI, which is the National Human Genome Research Institute. Eric's going to yell at me if I get it wrong, which is under the NIH in the US. So just to get a little more information about both of our amazing guests, this is, as I said, the second year we're bringing on the current president of the American Society of Human Genetics for this discussion. Last year we had Brendan Lee on, and this year we have Dr. Bruce Gelb, who is a renowned pediatric cardiologist and geneticist, serving as the Goal Family Chair and Director of the Mind Child Health and Development Institute at Mount Sinai, where he leads groundbreaking research into congenital heart disease and genetic disorders like Noonan syndrome. He's a trailblazer in using genomics to uncover the causes of childhood diseases and has received so many accolades and is a member of the National Academy of Medicine. He also directs Mount Sinai's cardiovascular genetics program and is really a leading voice in pediatric research worldwide. So, Dr. Gelb, thank you so much for coming on. And for, I don't even know how many episodes you've been on, Eric, this is Dr. Eric Green, director, as I said, of the National Human Genome Research Institute under the U.S. National Institutes of Health. And his career has involved directing a lot of major genome research, including the Human Genome Project, and is leading NHGRI's efforts in funding genomics research. How important is that? And this is our third year, Dr. Green, of doing this together. And yeah, I just love being able to do this. And it's a much more, I would say, casual episode because we're all going to be just sharing what has been going on the past year. And my thoughts are just coming back from the conference in snowy Denver. Dr. Gelb, you are now that we're ending the year, you're ending your presidency. Can you share a little bit about what the conference was like for you and just this year being the president and some of the thoughts that you've been having of just starting to reflect back?
Sure. It's been a busy year. In terms of Denver, I'll express gratitude. First, 30 inches of snow missed downtown. So we were grateful for that. So we were able to get in and get out.
I'm getting the wrong stats.
No. There were like 30 inches up in the hills a bit. And we heard about that. So the local commuters struggled, but the rest of us, it was fine. You know, I said in my remarks during my presidential address, I think we're still close enough to COVID to be able to really appreciate the wonderfulness of being able to come together. And I think you feel that very much when you were at the convention center. And I think people were happy to be together. And science happens better. It's a it's a human social activity, and you need proximity. And I think the fact that we were able to gather was really important. You know, I guess for me personally, at least, the highlight was giving the presidential address, which was a great honor and quite candidly felt like pressure to get ready. And the topic that I chose is one that is well known to people in human genetics, which is variable expressivity and incomplete penetrance. I selected it with the belief, and hopefully I convinced at least some people in the room, that these are concepts that have taken on additional urgency. We are moving into a realm, and I think it's reflected in some of the papers we're going to be speaking about later. It was certainly reflected in our science during the meeting, in increasing opportunities to do population-based screening with genetics. And the goal is a beautiful goal, of course, which is to find people who are at risk for various health problems that we can do something about. and catch it before really their health deteriorates and keep them either healthy or at least slow whatever that process is. That's a beautiful idea. But it is banging into a problem that is going to be quite variable depending on which genetic disorders we're talking about, whereby what we currently know in human genetics, which has been derived from studying individuals who have the problem or their close relative, their siblings, their kids, their parents, has given us a sense of how likely people are to get genetic disorders over time. But the lesson we're seeing again and again as we're studying large database population biobanks like the UK Biobank, now all of us, and then ones that exist at individual medical schools, is that actually the rates at which people are getting this disorder based on having the right gene changes is a lot lower than what we understood before. And that has real implications for how we roll it out and what we need to know in order to feel comfortable that a given trait is worth screening in the population for. So that was fundamentally my message during my talk. I'll just also say it is traditional at the meeting. We have a symposium that the president pulls together, which is the next day. My talk was on Tuesday, just before the election. The polls started closing back east. Yeah, but I was grateful to get it in. And then the next day was the symposium, and we had 3 speakers that were on topics that were related to that. And I'll just quickly say what they were. One was a wonderful historian, Greg Raddick, who's American but currently in the UK, and was talking about how this sort of argument about Mendelian disorders, so-called single gene traits, as complex versus simple, that goes way back to the early 1900s. And to imagine what the world would look like if we had thought of Mendelian in that more complicated way that they really are, rather than the simplistic way in which we teach them to grade school kids or middle school kids or even college kids.
Yeah, that was such a good presentation. I was like ferociously taking notes, and it really opened up my mind to think about these quote unquote straightforward Mendelian conditions in a different way. And it was just those, what was it? It was 3 presentations kind of back to back, all related. And that was amazing. We did a recap episode of the conference. That was episode 314. And I talked about that. And Dr. Raddick actually ended up listening to it and was like, thank you for that. And so it was just like, wow. I was like, all right, we got to have him on a full episode. I got to read his book first. So, over the holidays, I'll have more time to get, because I think it's a longer book. But I'm excited for that, because that was such an interesting mindset to me.
Yeah. Well, the cool thing was that he described a real life experiment where they tried teaching college students with the more complicated version rather than the simplified version. And in the end, they come out with people who have a much more nuanced view and are much less, genetic deterministic in their thinking, which is, I think, a good thing. So that was cool. A second talk was by Athena Davenport, who's an ASHG member and now leading our DEI committee. We just became a committee for the ASHG. And she talked about genetic modifiers for sickle cell disease. And, we don't have that many Mendelian disorders where we know the modifiers. And here's one where we know a lot. It's already being used for therapeutic purposes. So that's exciting. And there's more to do. And so that was an exciting talk. And then lastly was a friend of mine, actually, Scott Schwartzman, who's at Princeton, does quantitative genomics, mostly using Drosophila. And he is using that to study stochasticity or randomness, which also plays into variability in humans and something we know almost nothing about, actually. We just know it exists. Everybody says, yeah, it exists, but we haven't thought about it very much, and certainly it's been difficult to study. So I think as a package, it got into, I know a number of people came up to me in the meeting and were excited about what they had heard, and especially for younger people thinking about these things and what to do with their careers. I think there's a lot that can be, I'm confident this is going to keep geneticists busy for another 100 or 200 years. There's a lot to do.
Yes.
Let me jump in, Kara, and a few things about the meeting from my perspective. First of all, I want to personally congratulate Bruce, because I thought his presidential address was outstanding. His presidential symposium that he just described the speakers really were just wonderful, showcasing of some very important work. What I really like about the ASHG meetings is this ability for the presidents each year to put their mark, their style, their interest. It just sort of gets a chance in a very public forum to really reward the president for their service by, giving them a chance to really speak their mind about areas of science they're interested in, but also to showcase areas that they're really interested in. So, my own personal congratulations to Bruce for his tenure as president, but also for what he did at the meeting. He'll be, of course, the first to say he stands on the shoulders of dozens and dozens of people that put a meeting like that together. And that's absolutely the case for what Bruce did and always for what ASHG do as an organization. I think it's wonderful. It was a challenging year. Obviously, there was the distraction of the election. There was the distraction of the snow, at times that made some people nervous. But, the science was just, and the enthusiasm for the science was just outstanding. One of the things I pointed this out to a few people at the meeting, and I just feel like, and maybe I've even talked about it on this podcast before, I don't know, but one of the things that I just continually marvel at every single year that I go to ASHG now is that genomics is completely infused in the meeting. And maybe some people are going to say, well, duh, of course, genomics should be infused in a human genetics meeting. But maybe it's because I'm getting old, and maybe because I was there when the bruises were still hurting a little. But if you go back, not that many years, but if you go back to the early years of the Human Genome Project, genomics was not really welcomed at the ASHG meeting.
There was a divide there. We were chatting in the exhibit hall I probably took up too much of your time, Eric, but we were talking about that concept, and I didn't really I'd heard of that, but you filled me in a lot of it was challenging times. Not everybody was getting along at that point. It was genetics versus genomics for a while.
At first, the human geneticists they were worried about the identity of their meeting, and they were not very welcoming of these big genomic talks talking about the Human Genome Project. And I don't know all the reason for the sociology. And Kira, you wouldn't know about it because you're too young, but I found it astonishing because I was just a postdoctoral fellow at the time when the Genome Project began. And I do tell this story because it's true, and it's the only time I've ever served on a committee for ASHG was as a late postdoc. Maybe I had just become an assistant professor. So it was probably about 1992 or so. It was getting so tense, and the program committee was so seemingly uncertain how to infuse genomics that I got invited to be on the program committee. So I was on the program committee at a very junior stage because they thought I could come in, and I was simply asked, tell us what are the best things in genomics that we should try to showcase. And so I helped recruit abstracts and picked abstracts and held sessions, et cetera, et cetera. And what I would say is that's all history. It's all melted away. And now if you walk up and down those poster sessions, or you go to any random session you want at ASHG, there's a complete interdigitation of genetics and genomics. There is no longer anything tribal about it. And you just almost laugh that there ever would be any conflict, but there was. And thank goodness we're past that stage. And it is a wonderful meeting to just sort of see how, the applications of genomics are truly lifting up human genetics, medical genetics, and so forth.
It really is. And it was my first time. I've gone to being a genetic counselor. I've gone to the National Society of Genetic Counselors meeting, I think for the past 5 or 6 years, something like that, including the virtual years where I just did it from home. So that's what I'm used to, right? And then this conference is so much bigger. There's so many companies that I met in the exhibit hall that I just didn't even know existed. Dr. Green, when we were having that conversation, I looked up and I was like, yeah, you can spot the word genome or genomics so many times just in the exhibit hall we were in, and this company and that. So it really is integrated, as well as just looking at what all the presentations were and going around the poster sessions in the exhibit hall. I think there was just so much there. And, obviously we're mostly here in this episode, obviously we're reflecting back on the year. And a big part of that is wanting to talk about what were the biggest things to happen in genetics and genomics. And a lot of that comes back to what are the biggest publications. And when we started this series, the first one, I think 3 years ago, I approached Dr. Green. I was like, hey, you're a good person to do this with me. How do we figure out what to talk about? And you were like, hey, well, we actually already do all this work and, figure out this genomic medicine year in review. And I was like, oh, great. This can be the template for this conversation. So Dr. Green, did you want to provide a little bit more than that in terms of the context of putting, for the both of you, putting this paper together along with a bigger team, because this is what's published in the American Journal of Human Genetics every year?
Right, which of course is the Journal of the American Society of Human Genetics, which also brings another tie-in. Although I do want to emphasize that this year in review that I'm about to describe is just about genomic medicine implementation. It's
Thank you.
Depth and breadth of human genetics. So again, I also think we should make sure we talk about things that have been way cool in human genetics this year.
Way cool. That was a little Easter egg.
Oh, sorry. I use that phrase a lot. But
by the way, Eric, I wouldn't be doing my job if I didn't note it's one of our 2 journals.
Good point. Guys, that is journal. Point.
Yes.
But
and we'll throw links in the show notes for everything that we're referencing, people, because I know we're throwing a lot of acronyms and different journals around. So
as always, there's a story associated with the year in review. And the story is pretty simple, was that shortly after I became director of NHGRI, and I'm about to celebrate my 15th anniversary, actually in less than a week.
By the time this episode comes
Congratulations.
out. Yes.
Yeah, December 1, 2009, I became the NHGRI director. And about a year and a half later, we published our 2011 strategic vision, which was sort of the second installment of a strategic vision that the Institute published after the Genome Project. We published the first one the day the Genome Project ended. This was the next one. And this one actually put the phrase genomic medicine in the title. And it represented sort of the signature feature of me becoming the director, that I was going to start expanding our portfolio to embrace genomic medicine research as a key part of what the Institute does. When we published that strategic vision, one of the first things my highest level advisory group does, the National Advisory Council for Human Genome Research, this is the highest level advisory group to the Institute, was we created a working group to specifically focus on genomic medicine implementation. And that working group has existed ever since. It's called our Genomic Medicine Working Group. And that group meets, and I meet with them on a monthly basis, and they've done various things. But as the literature started growing over the last, now it's about 13 years, we started curating the papers and having a website that talks about what we think are the biggest accomplishments in genomic medicine. And so back in about 2019, and I think it might have been Bruce Korf who approached us, or maybe we approached him. I don't know, because he was the editor of the American Journal of Human Genetics. He said, why don't you pick your top 10 of the year and write it up? And so we did. We started that. And so now we have a standing invitation from the American Journal of Human Genetics to submit for their publication in their February and their December issue, a reasonably short paper and we pick and we vote. And it's like this whole big process to pick what we think are the top 10 papers published in genomic medicine and genomic medicine implementation. And so that's coming out anytime, because it's going to come out by the time this podcast comes out, it will be out in the American Journal. And that also serves as a sort of a little bit of a retrospective of the year to see what came out in the literature this year. And so we have the latest one that's coming out. It's called Genomic Medicine Year in Review 2024, and it features 10 papers.
And it's so helpful because I think in December, we're all reflecting back on the year in different various ways and in terms of our field. So my question is probably a hard one. What would be your top one? We've got 10 in front of us. Where do we start?
So I will politically avoid the question, categorizing it whenever people ask me which is my favorite child.
So they're not in order. They're just, this is the top 10.
Yeah,
gotcha.
But
I had to try, right? I had to stir the pot a little bit.
You could try. What I will say is when I look back, and I had read the paper, I had edited the paper, I'm a co-author on the paper, but I took a step back in preparing for this conversation with you and Bruce today. And I really found 2 things that struck me that actually made me really happy, and for different reasons, but they really did make me happy. Number one, if you go just through the titles of the headings for each of the papers, the word diversity or ancestry appears in 4 out of 10, which I think is really, really wonderful because it reflects the fact that of the top 10 publications by this working group, which of course is it's just a voting system. I'm sure we could get other people to come up with a different set of 10. But still, rising to the top, the cream of the crop of these papers, 4 of them had a focus or a major component related to human diversity, human ancestry. So I think that's incredible. And then similarly, one of the many criticisms I get, and when you're a leader of an NIH institute, you get criticized all the time, and that's fine. We have thick skin, and I actually like the debate. I like to hear what people have to say. Is I will frequently, when I give talks, people will say, you talk too much about genomic medicine, and we need to be using genomics where it's not about medicine. It should be more about prevention. What can we do to prevent illness? And, this all is the whole debate about, should we call it precision health? Should we call it precision medicine? Should we focus on medicine, which is about intervention with sick people, as opposed to health and prevention? So, all this has been debated for years by doctors, public health officials, et cetera, et cetera. But forget the titles. If you actually just look at the 10, 6 of them really relate to prevention, as opposed to, they really are about anticipatory genomics. Maybe that's even a phrase I've never thought of, but it really is about using genomics to anticipate. And I thought that was really wonderful because it takes a little bit of the criticism away from overly focusing on medical interventions using genomics, because they spoke to things that really set us up for prevention. So
I think it shows the progress of our field too, right? That it's like, that's what some of the most powerful publications that are coming out in this area are having those focuses, because we look back, and obviously both of you will have more perspective on this than me, but looking back, it's like when we started the Human Genome Project and looking at what genomes were included in that, and just a lot of the beginning databases, a lot of it was European ancestry. And that's something that ad nauseum I talk about on the show, and other guests talk about. Dr. Green, you've talked about on this show. And I think it's so important that we are making progress. And sometimes I will complain on this show, we're not making progress fast enough. But hey, let's take a step back and celebrate where we have made progress, because it's happening. I just get impatient. I want progress to move very fast, but it's happening. And I think that's important to highlight. Dr. Gelb, did you have kind of thoughts overall of just, these 10 cream of the crop papers?
Yeah, I agree very much with the comments Eric just made. I won't say it's the favorite, because I understand that's bad politics, but one in particular that speaks to the issue that you talked about was the one that came out of the NIH-funded, NHGRI-funded consortium eMERGE2, where what they're trying to do is take polygenic risk scores and make them applicable to diverse people. Because we all know that polygenic risk scores are based on GWAS, and GWAS, unfortunately, has overwhelmingly been done with people of European ancestry. And then the problem of what's referred to as portability has reared its head, namely when you try and take a PRS developed in people of European ancestry and apply it in particular to people of African ancestry, you wind up with very little power, very little predictive power. And so people are working hard on that. And it was impressive to me in that paper to see how good a job they did of thinking about which traits could you do, which of the PRSs work when you go to other ancestries, how well do they work, and you're going to have to tell people different things a little bit, maybe depending on their ancestry, but they're off and running, and I'm excited. That one was an appetizer, right? Like the entree is going to come when they've actually applied it. They've just begun to recruit and apply, so we'll see what happens. But the little bit of data we saw, I think they had like 2,500 people recruited and tested, is giving us a little bit of a taste of what it's going to be like. And I think it's going to be very exciting and very encouraging for rolling out PRS-based approaches to public health.
And this is data that came out of all of us, right, Eric?
They used all of us.
That's what I mean. Sorry, they
to
used some of the
verify
data.
their models, because all of us, of course, is very diverse. And so if you want to ask the question, does a PRS work in a diverse group? That's a great place to do it. And that's how they did it largely. And by and large, they only kept the ones where it worked.
By the way, Bruce just put his finger on a really important point that I think relates to what I was saying about seeing a lot more prevention. I do think polygenic risk scores, and you saw this at the American Society of Human Genetics meeting, polygenic risk scores, attention to them is incredibly high. Incredibly high. It is raising lots of issues around possibilities for prevention, raising lots of issues about deficits of data with respect to diversity and ancestry.
Yeah.
All that's the reason why this is being discussed. Lots of debate, rigorous debate at the American Society of Human Genetics meeting on whether we're really going to see, what's going to be the fruits of polygenic risk scores. I think reasonable people could disagree. Some are more optimistic, some are more pessimistic. But Bruce just said it beautifully. It's an appetizer for seeing what's coming next. And we don't totally know. But obviously, as Bruce pointed out, it came out of a consortium we're funding because we believe this is a really important area of research. And others are funding as well.
And only a third self-identified as white. I think that's very important to pull out in just terms of that abstract. Yeah.
Yep. Yeah. So anyways, I think this is an exciting area. By the way, the last comment I'd make about the papers as a group is that it's really heterogeneous. I mean, much more so if we were getting a little retrospective in the working group. And if you go back to, 2015, 2016, before we started publishing it, even if you looked at the papers, I mean, they were much more homogeneous and to be categorized as genomic medicine implementation papers. Now it's getting much more heterogeneous, which is wonderful. It's actually what you want.
Yeah, no, it very much is. So Eric, I think now you have to pick a paper to talk about, not your favorite, just something that,
what would be
off this list.
Well, it's not a favorite, but I did think, some of them just sort of caught my eye because they really showed a leapfrogging of advances. I mean, even the first one that's listed relates to hemochromatosis. I mean, we've been talking about hemochromatosis for so long in so many contexts. And, I could think about where the advances were during the Genome Project. I think during the Genome Project probably was when the gene was found, and now in a whole different, context, you're actually seeing how modern day genomics can be useful for managing that disorder from a genetics point of view. So, that one certainly caught my eye. I'm trying to think of other ones. There was at least one paper in there that I know started speaking to the brand. What are you going to say, Bruce?
Yeah, you were jumping. I would just want to chime in on the hemochromatosis. Sure. I think it'll help listeners who probably haven't read it to understand the potential power here. Like when they identify people who should, from a genetic point of view, be at risk for hemochromatosis, first of all, like 30% already had the diagnosis, so it had already been discovered. But of the remaining people, there were two things that stood up. One, amongst those who actually then got evaluated for it, half were found to have the problem and most of them, about, a third of them went on to treatment. And so, whether it's regular blood drawing or the chelation therapy. So that was a pretty big thing. But the other thing is an implementation question, because almost a third of people, even though they were told they had the genetics for hemochromatosis, never got evaluated. That's another area that we have to work on in medicine. It's not everybody's going to get the news, jump out of their house and immediately work it out. And that's also going to be a lost opportunity because some of those people are going to get sick and that could have been avoided. And how can we work on that? So there's an important little nugget of implementation there. And it's a population because it's, in sort of rural Pennsylvania where people tend to follow what their doctors say a lot more than, a more cynical place like where I am in New York. And so we have to think through that.
By the way, probably the other one I'd mention, again, I hate picking favorites here, but if you give this list to a bunch of high school students, and I get contacted by high school students all the time, they love CRISPR.
I'm with the high schoolers because that's the one I had to talk about.
Yeah, I mean, so why shouldn't they? Because it's something. I mean, and so the story about the retinal disease being treated with gene editing. Yeah, I mean, and there's more and more of these stories coming out, but that's just remarkable.
It is. And last year, Dr. Green, my personal pick was the FDA approved CRISPR treatment for sickle cell. And then This year we had on Victoria Gray, who was that first person and has been asymptomatic since her treatment in 2019, so 5 years ago. And so I've had this big focus, multiple episodes of the show this year focused on CRISPR and specifically that FDA approved treatment. And I often just bring it up in interviews and everything. And so to have another one now that, we have this paper of treating this inherited retinal disease with CRISPR-Cas9 genome editing is really interesting. And I was kind of learning about more of this. It's the most common inherited blindness disorder in children's. Anything in kids is pulling at our heartstrings too.
Can I pop in on this one, Kara?
Yes, please do.
Again, for people who haven't read it, this was a phase 1-2 study, meaning they're really just seeing if it was safe, and then they look to see whether it works. And because they didn't know for sure whether it would be safe, and spoiler alert, it turns out to be completely safe, but they picked, for each patient, they picked the eye that was worse off. And yet they still saw benefit. So I'm there going like, how quickly can we get that stuff into that person's other eye and try and preserve the so-called good eye, which probably is also experiencing visual loss, but just not as severely. And again, this is the appetizer, because I'm sure they're going on to phase 2 and phase 3 trials to move on to get it approved by the FDA. But the fact that they already saw a clear signal that it was working in a study really just designed to show it was safe is usually a very good sign in therapy development. So that was very exciting.
This is one that we're going to be following in terms of, all right, how are the clinical trials going? And then obviously having that celebration of, I'm expecting at some point an FDA approved treatment, just like we have for sickle cell with this, because it's just anything related to CRISPR is just so exciting. And I think it's amazing how fast this happened. We started the show in 2012. So 12 years ago, I started DNA Today, and there was a big CRISPR paper in 2012. And just the progress we've made in those 12 years, like I thought where we are now, I'd be in my 50s, 60s. I'm 29. This, to me, happened so amazingly fast. I don't know if you guys have a similar perspective in terms of just how fast we've been able to use CRISPR for treatment and not just on the R&D side of things and kind of learning about CRISPR. I mean, it still blows my mind. If someone is like, what's a topic you want to talk about? It's always CRISPR.
So the analogy I would make, and by the way, it pains me to hear you say your age, but that's okay. I'll get over
I know. Well, you referenced I was young at the beginning, so people that don't normally listen to the show.
The way you reference it by saying, this length of time, and of course you're only playing. But my reaction, when you say that, I have the exact same visceral reaction, but not about CRISPR. What I have the visceral reaction is I never thought because I got into genomics as a pathology resident, got involved in the Genome Project. And even when the Genome Project ended, even when we go back 21 years ago, we've sequenced the first human genome. If you would have told me in my lifetime, we would be routinely sequencing patients' genomes for less than $1,000, I would have there's just no way. There's no way. Now, I'm not 29 and I'm getting close to 65 in 2 weeks or something, but I really never thought I'd see the kind of routine genome sequencing we're seeing now already. And it's going to even, I think, just get more. But I know exactly viscerally how you're reacting, because it's when I look back, that's exactly what I look back at. I cannot believe in my lifetime, let alone my professional lifetime, that we're routinely sequencing genomes as part of clinical care.
It's only been 21 years since we finished the Human Genome Project, like in 2003, right, when it was the big, so that's remarkable. Dr. Gelb, what were you going to say?
Yeah, I was going to do a contrast, because when I started my career here at Mount Sinai, which was in the very early 90s, gene therapy was about to happen, right? So
that is true.
Right now, there's something where it actually took kind of the amount of time we would worry it might take, and it had its setbacks. And for sure, I think CRISPR therapy is to some extent building on the backs of that, because some of the lessons learned have been applicable as they move through. But I agree that CRISPR has gone from discovery to therapeutic approval in the time it has is nothing short of remarkable. And it's really only a beginning, you have the sense.
Yeah.
And for this disorder, like, there are no good therapies as far as I'm aware for this. And so this is really huge. This is exciting stuff.
No, that's a very good point. I think the 90s were, from what I hear, were just, it was like gene therapy was like, oh my gosh, this is happening. This is great. And then it's public
just around the corner.
Yeah, it was just like, there it is. And I think when Jesse Gelsinger died, that, and others too, I think that's the boy that's most well known, when he died in 99. it just, everything was set backwards. I think that it just, it really halted a lot. But it's like, it's great that now in 2024, we're at this point where we're like, okay, we've made so much progress, but could have made a lot more progress if certain things didn't happen, in the late 90s there. So what's our next paper we're picking? Again, we're not going in order. This is kind of just, very...
Bruce, what was the one that particularly grabbed you?
Well, I'll just point out, it was one of the papers was looking at how often people who carry genotypes, this was again in the Geisinger system, that put them at risk for malignant hyperthermia, which is a problem that can happen, around the time of surgery due to the anesthesia, actually had it. And the answer turns out to be like almost no one, even though a bunch of people who had gone through the procedure. So that caught my attention because you heard what I said. That would be an example where maybe the actual penetrance of the problem is quite low and serves, we need a bigger data set, but maybe serves as a little bit of an alert that you can't just jump from knowing somebody's genotype to knowing what we expect of them, medically, and we need to pick our spots and pick things more like hemochromatosis for our focus and a little less like for the malignant hyperthermia. I don't know what you thought of that paper, Eric.
Yeah, no, I agree. It's of great interest, and people have pondered about this for a while. Kira, can I insert a surprise from the year for me that wasn't necessarily in the paper?
A little bonus. I love it.
Sure. No, I'll throw it in. Actually, because again, in preparing for this discussion, I'm sort of thinking about what were my big surprises this year, or what were things that really caught my attention. And one of them, actually a couple of things I can say, but one of them in particular, and I think based on what we were just saying with CRISPR or genome sequencing, where do we think we will be 10 years from now, 20 years from now? Will it go faster than we thought? Will it go slower than we thought? Et cetera, et cetera. I was invited to give a talk at a meeting in New York City about 3 blocks from Bruce's office at the International Consortium for Newborn Sequencing, this ICONS group. And actually, Bruce and I had breakfast one morning when I was attending that meeting. And I'd never been to that meeting. The whole feature of it is newborn sequencing, both for ill but also healthy newborns. And this is also a lot of discussion over the last, increasing with the lower cost of DNA sequencing as, should we be sequencing healthy newborns instead of doing the routine genetic screen we do now? The one thing I'd say that I learned from that meeting is I was really surprised to learn, impressed to learn how many studies are going on around the world. There's some studies here in the U.S., but there are a lot of studies going on around the world. I knew the UK was doing some of this, but there's just many. And that is a growing area of research that I think is really an interesting one to watch. And I also think it's one of these things that, you almost want people to make their bet now as to, when will we have the majority of Americans, or pick any country you want, getting their newborn's genome sequence. And and I think reasonable people could really disagree substantially about that. And I think, but I became impressed by how much research is going on. I would also say, although I would have said this a year ago, that the notion of doing genome sequencing of acutely ill newborns, it just is now making total sense. And is
the record of 3 hours and something minutes,
so
that's
I wanted
wild.
to jump in on that. So I think that's really important to underscore. As president, I've been talking about that when I went to the Hill and met with staffers. I talked about this because one of the problems we've confronted, I believe, is although everyone here understands what the Human Genome Project accomplished, you still hear this language out there of like, it was kind of a bust, right? Like, show me where you changed healthcare. And to me, right now, we are transforming NICUs across the country and across the world, right? Like, basically, right now, there are NICUs that are doing rapid genome sequencing and that there are NICUs that are going to be doing rapid genome sequencing. That's all there is, because it's transformational. We're making diagnoses for rare disorders that we never made in NICUs. It is clinical full-time. We've moved beyond research. It's not an argument anymore, and the payers are rolling over on it. And of course, the costs continuing to come down makes that easier. And I just think it's such a huge triumph for human genetics and genomics, both, that we've got to keep singing that song, because when we get pushback about what have we done, this is an incredible story. And the actionability is reasonable. There are lives that are changed and saved and bettered because of this. And it's just transformational.
Well, Bruce, 2024 is the year I started saying, I say it in a lot of my talks now, I mean, genomics saves lives. I mean,
Yep.
You could argue around the edges about a lot of other things, application of genomics, but you get these stories of these acutely ill newborns getting their genome sequenced, saving their life. That genomics saves lives.
Yeah. And since we are interested in research, there's still lots to do, because the fact is, when you apply that technology right now, you figure out 40% of the cases. And I'm here to tell you, the other 60% are not environmental factors, right? Like, I'm going to say almost all of them are genetic too. We just don't yet have the wherewithal to figure that out. And how we're going to get there, I don't know whether it's going to be through long read or understanding non-coding better or whatever it'll be, but that'll keep us busy. But I think that we'll see continued improvement. It's already great, but it's going to get even better over the coming decades.
As will the utility of genomic information for early childhood. And I think in addition to all the studies going on, lots of people put microphones in front of me and say, what's it going to take before we're going to start sequencing newborns genomes routinely? And one of the things I've said is, when we show enough utility of that information, I think parents will start paying out of pocket. If and when we have sufficient amount of good, useful information that will be useful in childhood and retaining child health. So in any case,
just preventative, even if they have a healthy kiddo. Like I'm not a parent yet. I hope to be in years, but I would do that. Why not?
So I'm on the more, even though I'm a site PI for one of the studies that Eric is referring to, I think it is super important that the research is going on. And I think we have to look at it in a very open-eyed way and make sure we're looking at what we are getting right in terms of health, not just in terms of genetics. The risk here is that we just say we found X number of percentage of kids, 3%, based on the genetics, and assume that we're heroes, where time will show that actually far fewer have health problems. And that's going to be the key to differentiate between health and genetic findings.
Which ties into my interest in seeing all these international studies, because Bruce is right. This is research. I'm not saying this is not clinical implementation yet. This is research. And the fact that there's a good diversity of studies in diverse healthcare systems around the world going on, that's wonderful. Let me give my second aha moment from 2024, if that's what it is, or just to another surprise, is I pretty regularly, especially before the pandemic, now after the pandemic, since I become director, I try to do some international traveling to learn about what's happening in genomics around the world, and increasingly now genomic medicine around the world. And this year I happened to go to Australia for the first week in July, and I had gone there in 2012. So I waited 12 years, and what a difference 12 years makes. An amazing amount of genomic. I mean, first of all, in 2012, they were barely talking about genomic medicine. They were talking about building genomics as an enterprise, but not genomic medicine. And 12 years later, well, they're doing some great stuff. And there's a lot of really, really great work going on. And I'm not saying other countries are. There's lots of other ones, and I visit some of those, and I will continue to. But I really want to stress that, there's amazing things going on in the United States, but what's also very gratifying is the number of efforts that are going on where we're learning from other countries. And I really like to see that, because I also think that genomic medicine implementation is heavily context dependent on how it's going to work, and et cetera, et cetera. And we need to see this implemented in various types of healthcare systems and cultures.
Yeah, no, I think that's very important. And just as we close out, do we want to pick one more paper, or Dr. Gelb, if there's another kind of like Eric was doing of just, okay, this is something that I've been surprised by this year or focused on?
Well, I have to do this because one of the papers is one for which I'm one of the co-senior authors. So we got to do that one.
And that was I love it.
And it was a study that was funded by Eric's Institute. So there you go. It was part of the CSER consortium, the Clinical Sequencing Evidence Gathering Research Consortium. And here in New York, we had several institutions working together for something called NYC-ITSE. And one of the papers is about a tool that we developed called GUIA, which in Spanish means guide, which is designed for return of results. And the bottom line is we showed that we could improve parents' perceived understanding. And in particular, we served a very diverse group of patients and their families for this study. And we did particularly well, for instance, with people who self-identified as Hispanic. The reason I think this study is important is that, as pointed out in the paper, a tremendous amount of effort is ongoing to do the sort of routine pretest stuff where it's just iterative. Figuring out how to do return of results when they're positive at scale is something that's not been studied nearly as much. Here we did a randomized study and showed benefit. I think we're going to need, I don't mean that GUIA is going to be the be all and end all by any stretch, but I think if we believe in the vision of genome medicine, and Kira, you know this, there aren't ever going to be enough genetic counselors to each spend an hour to return result to every positive, particularly if we're doing population screening. So thinking through how we can get at this in a scalable way, in a way that's accessible to people, is something we need to keep doing. So again, this is a beginning, not an end, but I think it's an important topic. So that's why I brought it up.
Kara, what was the biggest surprise this year for you?
I mean, that's a good question. I think we covered so much, but I think I do look at, going back to rapid sequencing in the NICU. I mean, that is just, and even just the ROI there, like not just we get a kid a diagnosis and save their life. Obviously, that's going to be the biggest, but I can't imagine how expensive it is every day that a baby's in the NICU. And to be able to get them a diagnosis and less imaging and all of this different type of, trying to get to the end of the diagnostic odyssey, just fiscally, ROI, how is that not saving so much money? And I think, as Dr. Gelb was bringing up, that's why insurance companies are starting to be like, oh, wait, I think we should be getting into this. So I think that's part of it. But yeah, any kind of CRISPR thing is usually also going to be my answer. But I wanted to thank both of you for taking the time, especially during the busy holiday season, to come on and just geek out with me about this. And, I love doing this episode every year. And Eric, thank you so much for coming on every year and helping me organize it. And, I'm just, very much now focused on 2025 and what we're going to see and further developments in all of these areas. But I think especially as we talked about at the very beginning, the JEDI initiatives and all of that. So thank you both so much.
Thank you, Kara.
And Bruce, congrats again on a great
ASHG.
And Eric, thanks for letting me partner with you on this. It's been great fun.
Absolutely.
Thanks for watching DNA Today. To access all of our episodes, head over to dnatoday.com. We also have a lot of bonus content on there that you can enjoy. If you have any questions, comments, suggestions, guest pitches, you name it, send them in to info@dnatoday.com. We'd also really appreciate if you could take a moment to rate and review the podcast on Apple, Spotify, wherever you listen to the show. It really helps more nerds like yourself find the show. Also, if you like giveaways and other ways to connect with us, I recommend following us on social. We're at DNA Today Podcast. We also have a Patreon if you want to be the most level involved in the show. That's also at DNA Today Podcast. Thank you so much for listening and watching. Join us next time to learn and discover new advances in the world of genetics.
The genes of you and me, the genes of you and me, they're all made of DNA. We're all made of the same chemical DNA. We're all made of DNA.